You see this silhouette cutting across the sky, and you think you know its story. But almost everything you assume about it is wrong. Engineers once mocked its cockpit as absurd. Generals doubted it would survive its first decade, and rivals were certain it would quietly disappear. Instead, this small jet outlived them all, flew over 13,000 sorties in a single desert war, and rewrote the rules of modern air combat. There are bitter arguments hidden behind its design, a radical decision that horrified traditionalists, and a control choice that made veteran pilots laugh out loud after landing. You will hear why pilots who flew everything still speak about this machine with a strange, almost personal warmth, and why factories are building it again right now. Stay until the end, because the most shocking chapter is not the desert or the Balkans, but what this aging fighter is quietly doing in the skies today. Look up at the sky, and even untrained eyes recognize that silhouette. Sharp, lean, unmistakable, a shape that has defined modern combat aviation for decades. You are watching one of the most produced fighters in history, and yet almost nothing about its existence was guaranteed when engineers first sketched it. How did a small, relatively cheap jet quietly become the backbone of dozens of air forces, while heavier and more expensive rivals faded into museum displays? Behind this aircraft lies a story of bitter arguments, brilliant compromises, and battlefields stretching from desert sands to Balkan mountains and Middle Eastern skies. Stay with me, because by the end you will understand why pilots who flew everything still talk about this machine with a strange, almost personal warmth. To grasp how the legend began, you have to travel back to the 1970s, when American air power stood at an uncomfortable crossroads. Vietnam had just ended, and the lessons were brutal. Heavy, expensive fighters had not always won the duels they were designed to dominate. Generals and engineers quietly admitted what nobody wanted to say aloud. Maybe smaller, faster, cheaper aircraft could change the math of air combat entirely. Out of that doubt came the lightweight fighter program, a competition that would silently decide the shape of Western air power for the next half-century. Two prototypes stepped into the arena, the F-16 from General Dynamics and the F-17 from Northrop, each promising a different vision of the future. Test pilots pushed both jets through punishing maneuvers, and slowly, the F-16 began to reveal something the engineers had only hoped for on paper. In 1974, the prototype lifted off for its first flight, and observers on the ground sensed they were witnessing more than another test program. The aircraft turned tighter, climbed cleaner, and obeyed inputs with a precision that made veteran pilots laugh out loud after landing. General Dynamics walked away with the contract, but a winning prototype is still only a promise. The real story was just beginning. By 1978, the jet officially entered service with the United States Air Force, and almost immediately, the questions about its survival began to fade. Pilots who climbed into the cockpit found themselves rewriting their own techniques, abandoning habits they had built around heavier, slower machines. Word spread fast through Allied militaries, and orders started arriving from countries that had never seriously considered a single-engine American fighter before. Over the years, more than 4,600 of these jets rolled out of factories on multiple continents, an industrial scale almost no rival could match. Why did so many nations choose this aircraft over heavier, more glamorous alternatives, even when budgets allowed for something flashier? The answer was hidden inside the airframe itself, in choices that looked simple on a blueprint, but were genuinely radical for their time. Step closer to the jet on a flight line, and the proportions strike you immediately. 15 meters long, with a wingspan of just 9.5. Those numbers are not random. They represent a careful balance between agility, fuel capacity, and the structural strength needed for high-stress maneuvers. You are looking at a fighter built around a single engine, a decision that shocked traditionalists who insisted two engines were essential for safety. That single power plant, however, gave the jet a thrust-to-weight ratio that let it accelerate, climb, and turn in ways twin-engine rivals struggled to match. Top speed approaches Mach 2, roughly 2,400 kilometers per hour, while the combat radius stretches around 550 kilometers on internal fuel alone. Underneath the wings and fuselage, hardpoints can carry up to 7 tons of weapons: bombs, air-to-air missiles, ground attack rockets, and targeting pods. A 20mm cannon hides inside the left wing root, ready for the close-range moments when missiles run out and the fight gets personal. Yet none of these specifications, impressive as they are, explain why pilots fall for this jet. For that, you have to look inside the cockpit. Open the canopy, and the first thing you notice is something missing. There is no traditional control stick rising from between the pilot's knees. Instead, a small side stick sits to the right, mounted on the console, a layout that engineers proposed and traditionalists initially mocked as absurd. That side stick turned out to be one of the most important ergonomic innovations in fighter design, and pilots noticed the difference instantly. Under heavy G-loads, when arms grow heavy and vision tunnels into a grey blur, the pilot only needs tiny pressures to command the aircraft. Behind that side stick lives a fly-by-wire system that interprets every input through computers before the control surfaces ever move a millimeter. That system makes the jet aerodynamically unstable on purpose, trading raw stability for blistering responsiveness no human could safely manage alone. Veterans describe the sensation as the airplane disappearing, a feeling that the wings, the rudder, and the throttle have become extensions of their own nerves. The seat itself reclines 30 degrees, helping pilots stay conscious through the kind of turns that would gray out occupants in any older fighter. Every detail in that cockpit serves one quiet purpose: keep the pilot effective when the body is screaming and the air outside is trying to kill. Still, ergonomics alone do not win wars. The true measure of any fighter is how many roles it can play when the mission changes mid-flight. Maneuverability remains the jet's signature trait, the gift that lets it twist behind enemy aircraft and hold a firing solution against far heavier opponents. But agility is just one card in a much larger hand that this airframe has spent decades quietly perfecting. The same jet that wins a dogfight at dawn can return loaded with bombs and strike a bridge or radar site by afternoon. That versatility means a single squadron does not need separate aircraft for separate jobs, slashing logistics, training time, and operating costs all at once. Maintenance crews on the flight line tell the same story. Panels open easily, components swap quickly, and the jet returns to the air faster than its rivals. Year after year, modernization packages have arrived, refusing to let the airframe drift into obsolescence, even as new generations of fighters appear in the news. On paper, this all sounds elegant, but pilots and planners know that real combat is the only honest test, and that test was about to begin. In the summer of 1990, Iraqi forces rolled across the border into Kuwait, and a coalition began assembling in the deserts of Saudi Arabia. By January 1991, the operation called Desert Storm erupted into the night sky over Baghdad, and these fighters were everywhere from the very first hour. You could see them streaking low across the desert, dropping precision munitions on command bunkers, airfields, and armored columns hiding in the dunes. Over the course of that brief war, this single type flew more than 13,000 combat sorties, more than almost any other coalition aircraft. That number is not just a statistic. It represents an aircraft turning around, refueling, rearming, and launching again with relentless reliability. Pilots who survived that campaign returned with stories of jets that absorbed punishment, kept flying, and brought their crews home night after night. By the time Iraqi forces were pushed out of Kuwait, the jet's reputation had hardened into something very few new aircraft ever achieve. The desert was only the beginning, however, because the next decade would test the airframe in a completely different kind of conflict. In the 1990s, the Balkans erupted into a series of brutal regional wars, and once again these fighters were thrown into the deep end. This time the targets were not massed armored divisions, but bridges threading through mountain valleys, factories near civilian zones, and hardened command posts. Precision became the new currency of warfare, and the jet's ability to deliver guided munitions with surgical accuracy turned every sortie into a calculated message. Strikes that once required dozens of bombers were now handled by a pair of fighters carrying a handful of laser-guided weapons. Civilian areas surrounding military targets benefited from that precision, because each accurate strike meant fewer wide-area bombings and far less collateral damage. The Balkans showed the world that air power had quietly entered a new era, and this airframe had become its workhorse symbol. Yet there is one region where these jets seem to live almost permanently, logging more flight hours than anywhere else on the planet. Across the Middle East, the airframe has become a constant presence overhead, especially in the hands of the Israeli Air Force. Israeli pilots took the jet, modified it heavily, and used it for everything from interceptions to long-range strikes against distant strategic targets. In asymmetric conflicts, where opponents hide among civilians and ambush from rooftops, the fighter's flexibility proved as valuable as its speed. The same aircraft that once dueled Soviet-era jets now hunts radar sites, command vehicles, and weapons convoys threading through urban terrain. Each regional campaign feeds new lessons back to engineers, who quietly bake those insights into the next round of upgrade kits. Sensors, software, and weapons evolve, while the basic airframe, that lean shape born in the 1970s, keeps proving it has more life left. That ongoing evolution is exactly why the story of this jet refuses to end, even decades after critics predicted its retirement. The latest variant carries a designation you will hear more often in the coming years: F-16V, the modernized standard for a new generation. Inside its nose sits an active, electronically scanned array radar, a leap that gives the old airframe situational awareness comparable to far newer fighters. The mission computer has been replaced, weapons interfaces redesigned, and data links upgraded to share targeting information across entire formations of Allied aircraft. You can plug this jet into networks alongside fifth-generation fighters, and it holds its own as a sensor node, a shooter, and a quiet team player. Several countries that once seemed ready to retire their fleets have instead signed contracts for fresh production runs of this latest version. That decision is not nostalgia. It is hard math. Because per flight hour, the jet still delivers capability that more expensive options struggle to justify. Operators look at training pipelines, spare parts networks, and decades of accumulated tactics, and they decide that continuity beats reinvention from scratch. So while headlines focus on stealth fighters and unmanned drones, this older shape keeps appearing in fresh paint on brand new flight lines. That brings you to the central question, the one that turns a piece of hardware into something more layered and human. Why does this particular aircraft refuse to fade, when so many of its contemporaries are already parked in deserts as static museum pieces? Part of the answer is engineering, but part is philosophy. The idea that one well-designed platform can keep evolving instead of being replaced. Every upgrade, every new variant, Every new operator has added a layer to the jet's identity, turning a tool into a kind of living archive. You are not just watching a fighter. You are watching a design philosophy that quietly bet on flexibility over flash, and won the bet repeatedly. The lesson stretches beyond aviation, because it shows that proven systems, when modernized intelligently, can outperform entire generations of newer ideas. Future conflicts will keep changing, with new sensors, new weapons, and new doctrines reshaping how air power is delivered to a target. Yet as long as a fighting falcon climbs into a sunrise somewhere on this planet, the era of fourth-generation combat aviation is far from over. Think for a moment about what you have seen across this story. The prototype, the desert, the Balkans, the side stick, the radar, the upgrades. Each chapter could have been the end of the road, and yet every time the airframe absorbed the change and emerged ready for the next decade. That refusal to retire is what makes this aircraft a legend rather than just a successful product, and the story is still being written today. Now, it is your turn to weigh in on this journey through more than 4 decades of flight, combat, and quiet engineering brilliance. Which moment in this aircraft's biography surprised you the most? The cockpit revolution, the desert war, or the return to factories in the 2020s? Drop your answer in the comments below. Share which version you would love to see in a future deep dive, and tell us what you want next. If this story held your attention from the first silhouette to this final moment, hit subscribe so you never miss the next aviation legend we explore. Stay with the channel, because the sky has many more stories like this one, and together we will keep tracking the machines that shaped modern flight.